So hi everybody, I'm Pavel and I will talk tonight about cross-platform development using those two acronym technologies. But before we start, I think there was a long day for you in the office. So let's start with a little bit of exercise. I guess you've done that before. I would like to know who has actually any experience with the technologies I'll be talking about. So if anybody was using Kotlin Multiplatform before, please raise your hand. Cool, some. So anybody using that in production environment already, or just for fun? Awesome. So yeah, I'll try to provide some introduction for the rest who never heard about it. And about the second guy, the Kotlin Symbol processing, anybody using that? Awesome, that's cool to hear. So my talk will be mostly about combination of both. And the good thing is that we are done with the physical activities, and I promise I won't bother you for the rest of the talk. And before we start, I would like to do some sort of personal introduction, what actually brought me here. I do have my own mobile development studio, and maybe like 10 years ago, I used to be there in London working on application BBC News. And I attended Londroid Meetups on kind of a regular basis. So I'm happy that I finally have a topic which I feel is interesting enough. And I'm really excited to share it tonight with you. So thanks for Carol to make it happen. And I'm really happy to be there. So let's jump into the first kit we will be talking about tonight. Kotlin Multiplatform. Notice some of you are familiar with that. I'll try to do really a brief introduction. Well, it's Kotlin, a mobile development environment, and the cool thing on it is that it runs on both platforms in a native way. So this is like a really cool thing to develop on both platforms and share the code. There are two ways how you can operate. There is a module which is shared between the platforms, so that's where usually your logic goes or stuff which makes sense on both platforms, and then you can have platform-specific code, and you can interact between those two, and really simplifies the development. I won't go into much technical details. Hopefully you get the picture. This is an interesting aspect. There was a new version released this month, and we are on version 0.8, so that means we are already 80% on the way. So if you not really tried the platform, it's really exciting time to hop onto the bandwagon, because JetBrains, the company behind Kotlin and Kotlin Multiplatform, promised to release it this year. So yeah, it's a cool thing to be in. And this is a link to the GitHub repo, where is a curated list of libraries specifically for Kotlin Multiplatform. And there is a bunch of stuff for that shared portion of the application. There are people who really like trying to address stuff which they deal with on each platform and shrink it together and address it all together. So they are tools for stuff like database access, networking, access to, I don't know, shared preferences, you name it. And this is really like doing great, and that provides a lot of value, because then you're really getting to the goal where you actually write your code once and don't have to develop it on each platform. But there is one glaring whole in that ecosystem, the set of tools which are coping with the UI is quite limited, which is understandable because, yeah, Kotlin Multiplatform itself doesn't provide any tools. It's up to you, and there are other reasons maybe why that's happening that way, and we'll be talking about that. Oh, sorry, other way around. We'll be talking about that quickly. One of the problems we face with the UI, actually making a cross-platform UI is really hard. It's so easy to do it wrong way, and it doesn't really feel right. For example, if you have experience on one platform, you usually tend to use that expertise and bring it to the other platform. It's possible because Kotlin Multiplatform takes away the barrier of the other language for you, so it's very easy to bring it to the other platform as well. But often that happens that your application doesn't just feel right, so you write it Android way, and it doesn't really look okay on the iOS and vice versa. Another problem which I've seen a lot, there are toolkits, especially in that UI area, which doesn't do that much. Like I've seen there are maybe 3 or 4 libraries which deal with the navigation. No really actually views, just navigation between views. You have to plug in your native views for each platform, but it's cross-platform navigation. And I was really fascinated to see, well, they are clever, nicely done, very like clean, I would say. But at the same time, they are very difficult to work with, at least to my taste. Like if you're moving from screen A to screen B, sometimes you have to write like up to 3 classes for that, and it's very difficult to debug it. So that doesn't really make sense to me. So this is also one problem. Yeah, it should help you. That's the whole point of a Kotlin Multiplatform. It should make your whole development process more productive. And this is not. This is actually the opposite. And another thing is that, to maybe surprise of someone of you, there is basically no common architecture, and the reason for that is that well, there is even no common architecture on both on Android and iOS. You're probably familiar with Android development. You know that it's evolving over the time. There are many different. I wouldn't say specifications, but they are like guides, and they are not mandatory. You can use whatever you want, and people actually do use whatever they want. And the same on the iOS. It's not really enforced to use a single architecture, and it makes it really hard to combine those together and have some sort of architecture which works well on both platforms using Kotlin Multiplatform. So this is where I seen really like this is a opportunity for fresh approach for a lot of innovation can be done in this area. And when I talk about stuff I'm doing lately, I usually use this phrase, model-driven architecture. I think it really describes what I'm trying to do, and I'll tell you in a minute. So you have something which I call model, which is like just ordinary class or instance of class, the object. And then you use that definition, model class, to do some sort of presentation. One example could be that you use a model, and using some library like this, you can let the entire database layer create it for you basically for free. But we're not talking about database layer. We will be talking about the user interface. So what I mean, I give you a very basic example. This is a very simple data class written in Kotlin. There is just one property, the greeting. There is one function which basically sets some sort of value into that greeting. And then there is just a sprinkled couple of annotations to help the system to understand what my intention was. So there is some sort of like entry point, which also provides label. There is some sort of property which overrides. This is, if you can see, this is variable, so it can be mutated later, but I override it with editable set to false, so it will be read only. And then finally there is another annotation. If I put it next to the function, I mean this should be called from the UI, and UI will respond to it and create button for that. So if we see the representation for that, we'll get a sample, a very simple screen. I apologize for the fact it's actually a screenshot from iOS, but hope you don't mind. So that's what you expect if you touch that button. This is populated, very simple, and there is just that model, that definition, nothing else. The system generates the rest of the UI for you. So that's what I'll be talking most of the remainder of my talk. Actually, this idea is not really new. It was created by that guy like almost 20 years ago, and he did that in Java, I guess Java 1.6, and the UI toolkit was Swing, so it was for desktop. And what I tried to do is to bring it over to Android. I used Java reflection to process all those annotations, and I ran into two problems with that. One was performance, because it all happened at the runtime, and the second was some constructs are really difficult to do with Java reflection, stuff like generics and a bunch of others. So I really gave up at that time. I tried to implement it again using Kotlin annotation processor. That kind of worked. I created a nice POC, which actually worked well for me, but at the time I felt that I really wanted to generate application for me on both platforms. So basically I waited for a cross-platform solution, and for me cross-platform is Kotlin Multiplatform. So that's where it all meshed together and clicked together for me. And the missing piece was, I was referring to KMP, which is annotation processing for Java, but well, you can use it with Kotlin as well, but it's tied to Java virtual machine, because that's the model behind that, and that really doesn't work with native. So you can probably compile it on Android, but it won't work on iOS at any cost. So you have to use this guy. So I quickly, I've seen some people actually using that, but I quickly provide some introduction for folks who never seen it before. So what it does, it looks into your code. There are like 3 steps which are essential. There is class which is called Symbol Processor, and that class has something which is called environment. And from that environment, there are basically 2 important pieces. There is another class called Code Generator, which in turn allows you to create a new files. So basically generate new source file at the time of the compilation. And then there is also a logger, which is also referenced from the environment. And that logger allows you to put information or warnings. So if you your code analysis finds something is not right, you can warn a user into the build log, or you can even emit errors, and it halts the compilation, and it's just compile error, and you have to fix it. So that's a very effective way how to enforce any contract or API, which is very difficult otherwise. So it's a very powerful tool. And the last thing which is worth noting is there is a list of annotated. So this is like an entry point of the whole thing. So you you have any class annotated with the annotation which was in my previous, that entity on the top. So it signals the system that this is the class I'm interested to process, I'm interested to introspect, and I can either emit errors if something is not right. So it's completely safe because I can do bunch of things to make sure that nothing really like missing, everything is there what I expect, and I can generate a code. So that's the way how to work with that model-driven architecture in Kotlin Multiplatform. I found it kind of difficult to set up the environment. You have to build, or you have to include a new module for KSP to work, and then it's kind of difficult to set up the sources and then tell the compiler to actually take those classes in account. So I wrote an article about how to set up the project correctly, and there is a link in that article about, it's a GitHub project, basically empty skeleton, which generates a file for you in the shared part of Kotlin Multiplatform, so you can use it on both platforms, which is really like a good starting point. So if you never tried that, this is really a good starting point to get your feet wet and try it on your own. Both technologies can be put in testing very, very quickly. So we covered the way we'll use the technologies. We have a better understanding what those acronyms stand for. So now it's time to do some interesting stuff. So I promise you that I will focus on UI. So let's generate some UI. And I mentioned that the new architecture model is needed for what I'm trying to do, and I thought this is the correct architecture for me. I called it MVC, and that VC is in the brackets because the model is the dominant one. It drives or defines what the application does, and the view and controller is generated for you, is still there. But if you don't need it, it's available for you automatically without no effort. So it's really like a very efficient way how to create your application quickly. It runs, it works, and you can adjust it later. So I feel that really like brings you the most efficient way how to develop application. So I did implementation of that architecture, which I call object forms. And all the examples I've shown and which I will show later are done using that framework. And you might ask why we need new architecture. And when I thought about that, excuse me, when I thought about that, my answer would be probably that if you think the components coming in the common UI frameworks like Jetpack Compose on Android or Swift UI on iOS, actually, well, they are powerful. You can create beautiful interfaces with them, and they just look all right. But to me, they are really just a wrong level of abstraction. They are too small, too focused on tiny pieces, and there is stuff or problems which are difficult to achieve. And one of important things is that they are too tiny. They are very difficult to be processed with KSP and remove that boilerplate code you don't have to write and write it for you. So I quickly show you what I mean. Say this is you want to create a text field, just a plain text field, and you want to edit an integer in it. So what do you use? On Android, you have something like a Jetpack Compose text field, or you have a text field on iOS in Swift UI, which is basically the same. Start with Android. You have a value which makes sense as a string because you added the text field, but well, we want integer, so we have to deal with providing a converter on value change. So that's one thing you have to write. You eventually have to deal with the transformation to cope with multiple dots in your input, stuff like that. And you have to provide a correct keyboard. So it's quite a lot of stuff you have to do to set up a text field to be able to edit integer. It's just one simple example. It's similar on iOS. It's slightly easier in the fact that one of the bindings there is a format input, which basically allows you, well, it's implemented by all types like integer, date, and so forth. So you basically skip that step on iOS, but the rest is the same. You still have to set up the keyboard, set up some sort of conversion on submit. So there is a lot of work you have to do. And I wrote a little like overview what that component provides for you and what you have to do for that. So each component has a frame, like a rectangle on the screen, which is a subject for layout. So you place it to exactly where you want, pixel perfect. Then each component in Jetpack is a single view. It's a just single rectangle, and then there is that text view, or there is that button and nothing else. It's a single purpose, which is, well, obvious, but eventually it can be done differently and it can provide extra functionality. I'll get to that later. And as I already shown, the value binding you have to do on your own, and there is no architecture. As there is no architecture on the platform, it's not enforced. So again, you are up to, you do it right, but nothing really forces you to do it correctly. There is no check by a compiler that you actually do it correctly. And there is a stuff you have to set. I mentioned that you have to provide the right keyboard, and that list can be much longer. And the result of that, even to set up a single text field, is kind of expensive operation, and it's limited in functionality. And to solve that, I, in my architecture, introduced a new concept, which I call smart component, which does much more. And key for that it's actually a much longer interface, but there are two functions which are crucial. It's a set and get of value. You don't have to pay attention to the type because I get to that shortly, but there are two features which are really like crucial. That smart component is type agnostic. It knows about the type you are going to edit in it. And it provides you the functionality which is tailored for the type. And it's driven by annotation. So you already seen in that first example that you can add annotation and specify more precisely what you want to do. And again, you get some functionality for free. So this is the similar overview for that smart component. Same frame you can put anywhere on the screen, and you can lay out as you want. But you get an extra features, like you don't have to care about the navigation. The navigation is provided for you because that component is smart, knows more, and knows what you want to do with that. Again, I'll probably discuss that later if you have time. Important difference is that component can consist of multiple views. So there can be stuff like validation, or if it's some sort of like a complex class, there might be a drill down view, or it might collapse. So stuff like that you can get for free automatically. Also, you don't have to deal with the value binding because that's provided by the model, and it's enforced. You cannot do it wrong because then compiler won't let you go any further. And options are already set for you. You can override them. So if you want a different keyboard, you can do that, but you don't have to do anything. So it's much faster to create application that way. They are automatically provided, and you can optionally modify that. So that's like a key aspect to what you can do. this is also one important aspect, how those smart components cooperate with the rest of the code. I let my Kotlin Symbol processor to introspect my classes and generate dynamic adapter for each class. So back to example we already seen, I create this guy. It's not complete, but there are a lot of stuff which describes the class. There are like array of those properties, arrays of enumerations which might be there. There's an array of those callables, buttons which be created from those. You can have something about lifecycle stuff which is called on open, on close of editing. And then there is an extra method which we quickly look in more detail. It updates the UI from some sort of model. So that for model is stuff like it's a representation of the native UI in that shared code. So, well, what's important, if you look at those 4 lines, they look a bit weird. Like there is a you type it to some weird type, who knows what's there. Then you access the property on that. Again, no check, there is no try catch block because, well, it looks like a dangerous operations. There is accessing the property by the string, which is also like kind of shady. But this is generated by the KSP, and it's used by basically that model, by the system. So it's guaranteed to compile, and it's guaranteed to be correct. So you can do a lot of very dynamic stuff. This is basically like a glue which languages like JavaScript typically have. They are dynamic because everything can be converted to string, and it works. That's why some libraries in JavaScript are so powerful. Here you have the same, but you have also an extra safety of the type checking by the compiler, by the KSP at the compile time. So it's like you have a best of 2 worlds. You have type safety and you have the expressiveness of dynamic. And you are reaping the benefits of that. So I mentioned that the navigation is built in and you really don't have to do anything and it just works. It's provided by that model implementation. And you can have a very simple to use validation. I'll show you what I mean. This is another simple class. I'm sort of setting a couple of properties, and there is again one button which basically calls something like validate on this object. And let's have a closer look at 2 of those properties. So that's username and email. And by adding those 3 annotations, I want username never be empty. I don't want empty email as well. And I also want to check that this is like a valid email. So I only add those annotations and get some sort of interface out of it. And when I click on the validate, we've seen the implementation, you get the result of the validation. And if you click on that red triangle, you get actually a list of what's wrong. Both of those fail because you need to provide a value. You need to provide a correct email. So it's very easy to add functionality like that. And really, like this way, you don't have to do that much. So it's very powerful application which you get for very little effort of the programmer. I mentioned that there is a view and controller, and basically all of that gets generated per model. So I create complete domain-specific language for each model. What I mean by that, there is the view and all those properties in that data model are actually keywords in the language. So each model has its own like language space for that view, and it's very like declarative. It's so easy to work with that. So what it does, it specifies the order that username will be the first. This is some sort of group. So if there is a space like on a tablet, it will put phone and email on one line. So it gives you declarative expressiveness if you need it. If you don't provide any of that, you get just a plain form of those editing lines. And same goes for layout. You can tweak it any way you want if you want to. So like you get really best of both worlds. It's so expressive, so effective to develop it very quickly, and you still have full control over the look. This is another thing. There is another domain-specific language for the content. You can specify something which I call scenes. In the head of the scene, there is some sort of object actually instantiated. So that's how you instantiate the data that you edit in your application. You can see that there is another description, so you can jump from one to the next one. And there are two objects, and the system will automatically recognize they are present in parallel. So the UI will have two tabs, and you don't have to do anything. You get a tabbing interface just by introspecting your definition created by the DSL. And what you get from that, your client on iOS in this case, is just one line. You create the scenes, and that's all you have on the client. Everything else is cross-platform. Well, you can add your stuff if you want, but you don't have to. So this is like a view. Well, I show you. This is the Android version, maybe more readable. So some sort of activity. We override on create. This is system, and this is the only line we add. Again, create scenes, which we set as a content viewer. That's it. We don't use a bundle. Well, it's part of the API, but we don't use it because this maintains the state for that. And it's not needed. So if there is orientation change, it's managed itself. So you don't have to do anything. Very, very effective on your expressiveness. Probably just quickly, I guess we are slightly over time. You can combine it with native code, both SwiftUI or on Android. So if there's anything which is missing, it's very easy to combine it with just native code. So it gives you full control over the look of your application. If you don't like anything, you're good to go. And those smart components are customizable as well. So if you want to change anything, just provide a different implementation and good to go. So that's a screen my sales department wanted me to include. So those are like 3 different frameworks, React Native, Flutter, and Jetpack Compose Multiplatform. You can see the different technologies used. Well, React Native is actually not native. You can see that architecture is can be anything. Really, it's not enforced. And this is also just overview what kind of controls are behind that. Well, we are Android conference, but worth noting is that on iOS it actually uses SwiftUI, unlike, for example, Jetpack Multiplatform. So that means it can even run on platforms where only SwiftUI is available, like Apple Watch. Cannot be done on any other because they rely on UIKit, as Kotlin Multiplatform doesn't have native Swift interface. So we do it differently, and it actually works. And this is basically just a summary of the advantages I mentioned before. So it really, you have to write a lot of stuff which can be provided for you and can be edited later. So I mentioned that Kotlin Multiplatform is set to be released in the final form this year. I'm also trying to target this year for a release. I'm in quite advanced state. There will be more information available, and if you want to be part of the first beta round, drop me a line. I'll be happy to let you know when you can download actually. So I think that's it. Just my